Okay, so for example 3 says that the function is twice differentiable. Okay, that's important because that means that the function and its derivative are both smooth and continuous. So it gives you values for f and f prime. Okay, it gives you values there, and it asks you to justify some information. So part A says x coordinate of each relative min. Find the x coordinate of each relative minimum on f in this interval. Okay, well, if that's the case, we need to test where the derivatives are equal to 0. So the derivative is equal to 0 here and here. Okay, that means that we should test the slopes at that point. We know it's going down. It's going to be 0 slope, but it doesn't go back up, it goes down. So there's a 0 slope here, and it goes positive. There it is. There's our max. Or sorry, in this case, there's our minimum point. So we know that that must be the minimum point. Okay, so min at x equals 2. Okay, the reason why it happens is because f prime of 2 is equal to 0, and there's a change of slope. Okay, so there's a change of slope across that point. Okay, so part B says explain why there must be a value c for the interval -1 to 1 where the second derivative is equal to 0. Well, this is kind of implying the mean value theorem. And we can apply the mean value theorem because it says that the second is twice differentiable, so the derivative must be smooth and continuous. So if I take a look at these points here, between -1 and +1, okay, I'll do this in black. Okay, between these 2 points here, we know that the average slope is going to be 0 because it goes from, the average slope of the slope. Okay, so I'm going to find the slope of f prime, so which I'm talking about the derivative of the derivative, the slope of the slope. Okay, and I'm going to find the average slope. Okay, the average slope we can see is 0, so it's going to be 0 minus 0 over 1 minus -1, so the slope is 0. So that's our average slope. Well, if it is smooth and continuous, okay, so by mean value theorem, we know that there must be a second or a slope, which means that the slope of the second derivative at some point c between where c is between 1 and -1, okay, we know that it must be equal to the average slope, which is equal to 0. Therefore, f double prime must equal 0 at some point c, x equals c, and that justifies or explains question B. Okay, so part C then, the last part here, function h is a composite function, so we have f embedded inside the log function. It says find h prime of c. So first of all, this is something that we want to differentiate using the notation. So I'm going to say h prime is equal to 1 over f of x, and then applying chain rule, f prime of x. Well, I can figure out h prime of 3 if I know f of 3. Well, I think I do because it is right here. Okay, so I have at x equals 3, I have f of 3. I also have f prime of 3. So I'm just going to plug those in. So I get 1 over 7, okay, times f prime at 3 is equal to 1/2. Okay, so there it is. Okay, and I get those values come from there because when x equals 3. Okay, so simplifying that, my slope at 3 on the h graph is going to be 1 over 14. Okay.